It's Flashcard Friday is here at Math Science History, where every Friday we take a little idea and make a big discovery out of it. I'm your host, Gabrielle Burchak, and today's story is about a young scientist, a long, relaxing boat ride, and a revelation that changed the way we understand the death of stars and the birth of black holes. But first, a quick word from my advertisers. If you had the chance to listen to Tuesday's episode about black holes, you would have heard the name Subrahmanyan Chandrasekhar. In 1930, when he was just 19 years old, he boarded a ship called the SS Pilsner in Bombay, India, and headed for England. The voyage would take about 2 weeks, a slow crossing of the Indian Ocean through the Suez Canal, across the Mediterranean, and finally towards the English Channel. No phones, no internet, just the ocean, his books, a notebook, and a whole lot of time. Sounds like heaven. Chandrasekhar wasn't planning on revolutionizing astrophysics on this trip. He simply wanted to get to Cambridge University, where he would begin his graduate studies. But somewhere between Bombay and London, a thought began to brew. He started wondering, what really happens to stars after they run out of fuel? Most scientists at the time believed that stars simply cooled down into white dwarfs, dense, faint stars about the size of Earth, and that was it. But Chandrasekhar, curious and precise, wasn't satisfied with a simple answer. He cracked open his notebook, and while the ship gently rocked over the waves, he started doing the math. Using the principles of quantum mechanics and Einstein's special relativity, both relatively new fields at the time, Chandrasekhar started calculating the forces at play inside a collapsing star. In a white dwarf and other dense stellar objects, electrons provide the pressure that counteracts gravity, which stabilizes the star and stops it from collapsing further. Imagine a star like a giant game of tug-of-war between two forces. Gravity pulls everything inward, trying to make the star collapse, and pressure from the tiny particles, which are called electrons, pushing outward, trying to hold the star up. This outward push is called electron degeneracy pressure. So in stars like our sun, the electrons push hard enough to win the tug-of-war, and the star becomes a small, very dense white dwarf. So Chandrasekhar realized something shocking. If the star's mass was too great, electron pressure wouldn't be enough. Gravity would win. He crunched the numbers. The mathematics that he used included the math from Einstein's theory of special relativity, as well as new math theories used in quantum mechanics that included Wolfgang Pauli's exclusion principle and statistical theories presented by Enrico Fermi and Paul Dirac, known as the Fermi-Dirac statistics. He recalculated, he checked again, and he discovered that above a certain mass, the outward pressure doesn't grow fast enough to beat gravity, and the number that he found was 1.4 solar masses. In other words, the limit of the maximum mass a white dwarf can have before it collapses even further under its own gravity is 1.4 times the mass of our sun. Chandrasekhar discovered the cosmic tipping point, and this now famous value is called the Chandrasekhar Limit. So above that limit, the star would collapse into something else, something much stranger than a white dwarf. It could become a neutron star, or if massive enough, it could collapse entirely into what we now know as a black hole. When Chandrasekhar arrived at Cambridge, he was thrilled to share his findings, but the scientific community wasn't ready. As I noted in my previous podcast on black holes, Sir Arthur Eddington, one of the most respected astronomers of the time, publicly ridiculed Chandrasekhar's work. At a major meeting of the Royal Astronomical Society, Eddington dismissed the idea, saying there should be a law of nature to prevent a star from behaving in this absurd way. So imagine being 20 years old, halfway across the world from home, and having your groundbreaking work mocked by one of the top scientists alive. Chandrasekhar was shook and considered quitting physics. But he remained silent and stood firm. Quietly, persistently, he continued his work. He was resilient. And eventually, the rest of academia caught up to his brilliance. Today, we know Chandrasekhar was absolutely right. His calculation was one of the first steps toward the modern understanding of black holes. Without the Chandrasekhar Limit, we wouldn't have a framework for what happens when massive stars collapse. His work opened the door for the discovery of neutron stars, the theoretical foundation for black holes, and the later work of scientists like Robert Oppenheimer, John Wheeler, and Stephen Hawking. Every time we talk about black holes, swallowing stars, or collapsing space-time, it traces back to a teenage genius doing math on a ship's deck in the middle of the ocean. Gives me goosepimples. So there's something beautiful about this story. In the stillness of that ocean voyage, away from distractions, lectures, noise, Chandrasekhar's mind had room to wander, to question, and to create. Sometimes the biggest discoveries aren't made in crowded labs or noisy debates. They happen in quiet moments with nothing but time, imagination, and a notebook. So here are some great takeaways for today's Flashcards episode. 1. Time to think is time to discover. Sometimes when we step away from our busy schedules and constant noise, we give ourselves the space to ask new questions and find surprising answers. 2. Being challenged doesn't mean you're wrong. Even when the greatest minds doubted him, Chandrasekhar trusted his math and his instincts. It's a powerful reminder that truth isn't determined by popularity. 3. Small beginnings lead to big universes. A single teenager with a notebook on a ship changed the course of astrophysics. You don't need a fancy lab to make an extraordinary discovery. Sometimes you just need curiosity and courage. And 4, resiliency gives us the ability to see it through. Sometimes sticking with something and seeing it through will empower you in ways unseen. When you apply resiliency, you are better equipped to cope with mental challenges and even anxiety and depression. Additionally, it can even give you a positive outlook on life. Subrahmanyan Chandrasekhar embodied these 4 characteristics that serve as an inspiration for those of us who feel like our challenges can be insurmountable. Additionally, he embraced curiosity and the determination to continue pursuing his theories in the face of adversity. And as a result, he would go on to win the Nobel Prize in Physics in 1983 for his work on stellar structure and evolution. His journey literally started at the age of 19 on a boat ride, emboldened with a mind willing to follow the math wherever it led. Along the way, he asked himself some bold questions and never gave up answering them. He encouraged his students to ask bold questions and likewise encouraged them to never give up. His path is fascinating, and interestingly enough, when I was studying physics, my physics professor, Jean Lecuyer, encouraged me to become a student teacher. And it was really inspiring because I was young and impressionable, and I thought I would have a tough time as a woman studying physics. But Professor Lecuyer was very supportive. And as I'm saying this right now, and I got goosepimples, I'm going to admit it, another one of my physics professors, John Gers, just texted me. It turns out that Chandrasekhar was Professor Lecuyer's faculty advisor for his doctoral thesis. So yeah, it's a small world. It's a very small world. And I wouldn't be doing this podcast talking about the amazing wonders of science, math, and physics if it wasn't for the encouragement of the professors in my life. So eventually, Chandrasekhar's path kind of led back to me. And I just found this out and I'm just thinking this is so insanely cool. So dive into the world of science because you never know where it's going to take you. You never know who you're going to meet. You never know who's going to inspire you to ask those questions that keep moving you forward. Science is truly a wonderful, mind-opening, mind-blowing experience. And I'm so excited that I get to share it with you. Thank you for listening to Math, Science, History. Until next time, carpe diem.